The egg is completely surrounded by a protein coat. And this protein coat, called the zona pellucida, serves many different functions. But the first thing it does is to select which sperm is going to get inside. And it bases that selection on the shape of the sperm head and on the quality of that motility. It has to be strong, swimming very strongly and very determined to get through this protein coat. Once that happens, though, the protein coat hardens up and prevents any additional sperm from getting inside the egg. As the embryo develops over the next 5 days, the embryo doesn't increase in size. Every time the cells divide, they're half the size of the original cell. But this protein coat remains intact and helps keep all the cells together until it's the right time for the embryo to attach and implant. That occurs at the blastocyst stage, and at that time, the embryo starts to expand, and it starts to stretch this protein coat in the attempt to break it. Now, when the embryo is in the fallopian tubes, it's exposed to a mild solution of enzymes which thin out this protein coat. And so that makes it easy for when the pressure builds up inside and the embryo is trying to get out from inside, that protein coat will break. We don't have those same conditions inside the laboratory. So to make sure that the embryo can hatch out of this protein coat, which it must do in order to make direct contact with the lining of the uterus, the endometrium, we do something called assisted hatching. This is where we make a hole about 1/3 of the way around the equator of the protein coat so that it can open up, much like Pac-Man. And so the embryo is not impeded in any way. Now, it's still contained within this protein coat at the time of the transfer, but it can get out very easily after it's been transferred into the uterine cavity. So that's called assisted hatching.